Okay, today we're on 6.7, which is called the remainder and factor theorems. These are two theorems that we're going to use to build on, getting to kind of the finale of this chapter. That's going to be a stepping stone for us to solve polynomial equations that can't be factored like they could be in yesterday's lesson. So when we do other things, there's certain other steps that we need to be able to take that we're going to use to put a whole bunch of pieces together for this. So we're going to put together the synthetic division, the factoring, these things, what we do in the next section, all kind of together in section 9 of this chapter. So the first thing you need to know is what is the remainder theorem. The remainder theorem, I'm not going to make you memorize this, I just want you to copy down and know what it says. It says if you have some polynomial and you divide it by x minus a, the remainder is the constant f of a, and f of x is equal to q of x, which is the quotient, times x minus a plus the remainder. So all that means is you have the quotient times what you did plus the remainder, and you should get back to where you started. So we're not I'm not going to make you worry about that too much. I just want you to know what it says. And it leads us into what we really want to do is apply it to this synthetic substitution. So we're leading from the remainder theorem into synthetic substitution, which is an application. So this is the exact same thing as synthetic division, but now it can help us actually evaluate functions. It makes life a whole lot easier. So synthetic substitution is when synthetic division is used to evaluate a function. So if I say f of 5, we can use synthetic substitution to do that. Okay, example number 1. It says if f of x is equal to 2x to the 4th minus 5x squared plus 8x minus 7, they want us to find f of 6. What we do is simply use synthetic substitution by using synthetic division. So I set this up so we have 6, and then I do my things. We have 2, make sure you have a 0 because the cubed is missing, minus 5, 8, negative 7, and we're going to do synthetic division. Bring this down, so that's 2. 2 times 6 is 12. 12 plus 0 is 12. 12 times 6 is 72. Add, we end up with, we end up with a 67. So 67 times 6, I'm not doing this mentally. So 67 times 6 gives us 402. 402 plus 8 is 410. 410 times 6 gives us 2460. Minus 7 is 2,453. And so if you were to plug in 2 times 6 to the 4th power minus 5 times 6 squared plus 8 times 6 minus 7, we get 2,453. So doing synthetic division actually gives us the same exact answer as if we just substituted in 6 for the equation. And in my opinion, that's a whole lot easier to do than sitting there substituting in and putting it on the calculator. So, the depressed polynomial is the quotient of a polynomial divided by one of its binomial factors. So when you do synthetic division or even long division, you're finding what we call the depressed polynomial. All that means is you've taken one of its factors out of it. So we've done that already. And now the factor theorem. The binomial x minus a is a factor of the polynomial if and only if f of a equals 0. So what we're saying here is if we use synthetic substitution and I plug in a value and I get 0 for a remainder, that means that that factor, that number, is a factor of the polynomial. More practically, let's see how this works. I think it's a lot easier just to practice it. Show that x plus 3 is a factor of x cubed plus 6x squared minus x minus 30. So what I do is I take this, remember we take the opposite of this, so negative 3, and I want to show it's a factor. So I put all my coefficients, and I need to show that my remainder is going to be 0. If it's 0, that means this is a factor of that polynomial. So I bring down the 1. 1 times negative 3 is negative 3, plus 6 is 3, times negative 3 is negative 9, plus negative 1 is negative 10, times negative 3 is positive 30. We add them up and we get 0. So now I have x squared plus 3x minus 10. And they want us to find the remaining factors. So what do? I factor it. I say this is going to be x plus 5 times x minus 2. So this whole polynomial factors out into the one they gave us, x plus 3 times x plus 5 times x minus 2. And we're now to the point where we can factor polynomials bigger than quadratics. We can do cubics and quartics and other things. So right now we need to be given one of those. Eventually, in the next section, we'll be able to find what those things should be without being given them. So here, we find out that we can actually factor cubics and quartics and other things using synthetic substitution and then other factoring techniques. So another example. Now, this is using volume and things, but don't let it throw you off to what they're really asking you. Okay, so this is some test taking things, because they would give you this type of a problem on an SAT test. And they would say, here's the volume of a rectangular prism. Find the missing measures if one of the dimensions is x minus 4. So if you have some cube, and I know one of the dimensions is x minus 4, they want me to find the other two dimensions, right? So that means I have to divide this by that. So I'm going to say, okay, positive 4 with synthetic substitution, I get 1, 3, negative 36, and 32. Now I should get 0 if I've done this all correctly, because they're telling us that's a dimension. So 1 times 4 is 4, plus 3 is 7, times 4 is 28, plus negative 36, excuse me, negative 8, times 4 is negative 32, and I end up with 0, which is exactly what we wanted. So then I end up with x squared plus 7x minus 8. What do? I factor that. And I say, okay, these are my remaining dimensions. My remaining dimensions are x plus 8 times x minus 1. So the whole dimensions, this thing, the volume separates out into the one they gave us times the ones we just found. And again, we're able to factor these things using synthetic division and factoring techniques. So your homework there is going to be page 359, numbers 11 through 27 on. Again, most of that just using synthetic substitution in different ways than we have before.